Welcome to our talk. It's Why is CSP Failing? Trends and Challenges in CSP Adoption. This is work by me, Tobias Lauinger, and William Robertson from Northeastern University. So the World Wide Web, we all know this. It's this vast distributed system for using it for e-commerce and picture sharing and everything else. And but we still have these, right? So these sites having a high-paid, smart engineers and cross-site scripting is it's still there. So I mean, this shows it's a hard problem. It's not going away. So there are various countermeasures, client-side filtering, server-side filtering, but I mean they work with varying success, but there's no real solution. But recently people have been working on CSP, and so this has this promise of being a solution. So CSP is client-side, so in the browser, enforcing policies. So what we're assuming here is that there is a safe or secure channel between the server and the client where these policies can be transmitted. And we are also trusting the browser to enforce this in a correct way. And so these are document specific. So for each document that's being requested, server can send this whitelist of resources, so to which hosts can this website connect, can this load inline JavaScript or eval code. I mean, this defaults to no. And what can this do? So this can effectively prevent modifications to the site or data leaks. For example, somebody's sending off a cookie through an image. There's two modes of operation. One is report only. So the browser will monitor whether something unexpected happens, and if this occurs, it will communicate back to the server what's going on, or alternatively enforce these. So if something unexpected happens, this will just be blocked in the browser. It's a recent standard. We have currently version 1.0 with version 1.1 in the making. And pretty much all browsers support this. So Chrome, Firefox, Internet Explorer partially, and also some mobile browsers support this. So pretty much any browser people are using, it's most likely going to have CSP. This is being delivered as an HTTP response header, or which is a little bit discouraged as a meta tag. And I mean, just to summarize, so this is it both works and it's readily available. How does this look like? If we connect to a server that is supporting or that is using CSP, we are pulling this header, look for CSP, and this what we see here is that the default source is self. So all resources should either come from example.com, or for script source or style source is being replaced with static.example.com. If a violation occurs, then it should be sent back to example.com/reports. Okay, how would we use this? So if this is configured for a website, and we would move all inline scripts to files. We would stop using evals, so we would very nicely architect the site, remove, move JavaScript to specific domains to separate this nicely. And if a violation would occur, then this is what it would look like in the browser. So there would be no visible indication in the user window itself. It would be exclusively in this console, and so this is what an attack would look like if it's being caught. It would just go away. So CSP works fine, and we had this question. So CSP is good. How does it impact the web? So this is just going to solve all problems, and this is how we're working on this question. So first we are curious who is using it. So which websites are using this, and how are they using it? And if there's some shortcomings, is there a way for us to improve this and push this forward? And the contributions of our paper are so we did the first long-term analysis of CSP adoption in the wild. We were investigating what challenges people could run into if they want to adopt this for their sites. We adopted the feasibility of incremental deployment. So if you start out with something, the policy not being optimal, but how would we go from suboptimal to optimal, and we suggest a couple of avenues how to enhance this. We also released an open source library for tweaking these policies. Okay, so question: who's using CSP and how are they using it? So we had this. We started working on this in December 2012, and so we just started crawling the Alexa top 1 million. And so for every entry that we had there, we were connecting in through HTTP and HTTPS to this host, and we also prepended www. We used an up-to-date Firefox user agent, and I mean, what you can see here is we connected to only the front page. So this was a trade-off. So we could either try to make a deep crawl, but we would still have issues. I mean, we cannot log in automatically into every website. Of course, we are missing sites like, for example, Twitter. Right? They're using CSP, but only for logged-in users or on their blog. So what we're showing here is a bound. We're not going to catch all sites. So what other headers do we look into to put this into context? So P3P is a platform for privacy preferences. It's mostly a legacy header, which is used for managing of cookies in Internet Explorer 6. DNS prefetch control is a privacy-related header which allows the server to override the default in the browser whether host names should be resolved ahead of time. XSS protection is client-side filtering. This can be turned on or off. Content type options allows to disable MIME type sniffing. Frame option can block iframing of a site. HSTS allows to provide a more secure HTTPS setting, so a user can be disallowed from just ignoring unsafe certificates. And CORS is a technique where a website can tweak the same origin policy, so XHR can be sent to other domains than the one specified SOP. So what we see here, CSP is the black line on the bottom. So out of all these headers which we are looking at, CSP was far off. I mean, this plot is logarithmic, so the number of hosts that we found, I mean, these are the top 10,000 plotted from 2012 to April 2014. It was really not a lot. And what was also interesting is the fluctuation here. We found that out of this total of 140 hosts that used CSP at any time, 110 were used by Google. So they were using sampling for mixed content, so HTTP and HTTPS, with a sampling rate of 0.8% or so. So out of all these that we see here, only 30 were not by them. And what we also see is that the rate at which CSP is picking up is lower than any other header which are more niche, like for example like HSTS. And surprisingly, P3P was the most popular, which where most of the policies were actually invalid. It was just an free-form explanation why P3P is not being used, and only a few of those were actually good. So what we also did next is we drilled down in this snapshot of top 1 million. And what it is, we split this into logarithmic brackets, so 1 to 10, 11 to 100, etc. And so we are curious, how is this usually distributed over between popular and less popular sites. So in the top 100, only 2 sites use this. In the least popular bracket, it was just this very small number. And in contrast to CORS, which was way more even. So all brackets were between 0.7 and 2.6. So this was pretty flat and even. So what does it mean? More popular sites are more likely to adopt CSP, but I mean, this likelihood is still low. So 2 out of the top 100 was pretty much the best bracket that we saw. Then we looked into these policies that were used, how do they look like, so how do these help? And unfortunately, it was 815, and out of these, only 23 were actually collecting reports. So what this means is that the majority of sites, they might be able to catch attacks, but if this would happen, they were not aware of this. So in a way, it's good. They're using it. On the other hand, they could be using this better to be aware of what's going on their site. Report-only mode, only 35 sites. And what's interesting, we found this Norwegian bank. They used to use CSP in report-only mode, so they were collecting these violation reports, and at some point they switched to enforcement. So what we were assuming is that they were learning what's going on the site, and then they compiled this list of violation reports into a policy that they enforce. But what was strange is they had this extremely long list of sources. So it was 74 sources, and they're pretty random. So we tried to manually look into this, and many of these were not connected to the site in any way. So this was interesting for us. Other than that, we saw then these policies which were used by sites all over the place usually would allow unsafe inline, which strongly marginalizes how strongly reduces the benefit of CSP, and will also allow eval. So for people that were exploring these sites, it would not make it so much harder for them. Okay. So the next question was, can we do something about this? So can we make this better? Can we improve the adoption by generating rules ourselves? So can we both make higher quality rules and can we maybe just generate rules for sites that don't have any CSP at all, and then maybe try to retrofit this somehow through a Chrome extension or HTTP proxy? So I mean, there's three ways we could think of how to create these. Obviously, manually go to the site, look at it, and then come up with these policies. This is how we assume that most websites are doing this, and this might also be a reason why it's not that popular, because it's related to quite a lot of work. It's a tedious task. And so how to automate this? One, we could collect violation reports by users. So we just block everything and then just see what kind of response we get and combine this into a policy. Alternatively, write a crawler and then get these reports. So how does this look like? We have these violation reports. If we were to set image source to none, so no images shall be loaded, we go to a site that has an image, the browser would send this report. So we blocked this URI, pic.gif, this violated directive image source, and this is the URI where this happened. And by combining these three, we could assemble a policy for this document that would allow for this image to be used. Okay, so how do we go ahead here? We just we used 4 websites we had control over. We added these headers. We just disallowed everything in report-only mode. We just collected all these reports for a couple of weeks, and then we figured let's just use these violation reports and derive a list. So let's derive a CSP policy for the entire site, which which also means we are trying to do this not per document, but for the whole setup, for the whole domain. So this is one of the super simple website. It just had so we set default source. So this is a manually derived rule, something that we would expect for this extremely simple website. Image source was self. It had some inline data and style source. So when we ran our tool, what we received was this. This was surprising to us because there was a lot of resources included which had absolutely nothing to do with this site. So there's superfish.com, which is download or shopping bar. There's googleapis.com, and there's all these other things which have nothing to do with this site. So we're curious, where is this coming from? There must be some source of noise that is affecting our data collection. So by looking closer into this, we found that Chrome extensions are a big offender in this. So what happens is extensions like AdBlock, they modify the site, insert some JavaScript, and this CSP that is sent down by the server is conflicting with this what these extensions are doing. So these 3 are the most popular ones. What we also found is extensions are technically allowed to change the HTTP headers. So we found one extension that was just removing this or changing these rules as they were passing by, which can't make sense. But it was surprising this is actually being enforced on extensions because they are like software that a user installs, and you would not expect a website to tamper with this. And also modifications in flight. So there's some mobile ISPs or Wi-Fi providers that were just injecting ads or other JavaScript into the sites, and we were catching those too. And here one could argue that this is legitimate to be flagged as a violation, because this is probably not anticipated by the user. And so it was a question: can we filter this somehow? Because we had these legitimate and illegitimate violations, and we went through some manual labeling to separate these. But the question was, of course, can we build a tool to do this? Do we have to do this by hand, or can we just sort this? So this is a rank plot. We're comparing here the rank versus the frequency of both legitimate and invalid ones. So we see that these most popular legitimate ones are way ahead of the most popular invalid ones. But then at this point, we're running into trouble because there's more popular invalid reports than the least popular valid ones. So just sorting by frequency and saying this is popular, this is not, would completely fail. Okay, so we continued. Another question was how long does it take to how long does it take to have a good policy for a site? I mean, our intuition was more data is better, so we just figured the longer we collect, the better the output is going to be. Turns out for this site, after 2 weeks, we had all the required policies, and I mean these last ones we caught were just hidden on some parts of the site which were not exercised often. But these invalid reports would just come up more frequently than these that we were actually looking for. So there was no clear way to say this is a good point to just cut off and be done. So it really depends on the site, and there was no obvious way to do this automatically. Okay, so we figured we have to get rid of this source of noise. So we said we're going to set up our own trusted environment. We just got a Chrome browser, we wrote an extension that would go to sites, click links, and let's see how this works. So we're rewriting the HTTP response in a browser, in a proxy, and we would also there cache the violations. So the advantage here is we didn't have any semantic gap to an actual client. So it's the same environment, it's just Chrome. If we would have used Phantom.js or something like this, there would be possible drawbacks. And we used this, so we exercised this against the 4 websites which we looked into earlier. Also, we used this on a couple of websites that had manual CSP rules to see how well our tools fare. And we also used this against some complex websites that had a lot of ads, just to see whether we can generate good rules here. So the questions we had is, are these policies stable? So if we go to site device rules, go back a week later, rerun this, are these rules the same, or are these different every time? Of course, if they're changing every time, then our tool cannot do anything. So what we need here is that the rules are stable and they just work well over a long time. Also, how secure are these policies? So are we actually adding anything to what the site is doing? Because if we just whitelist everything, maybe similar to this Norwegian bank which had 74 sources, then we are not helping here a lot. And so to evaluate this, we compared this against manual browsing, basically just to see is our crawler working well enough. Also, we compared to the sites that use CSP as ground truth. So what happened is the stability varied strongly. So some sites, so mostly this was depending on ads. CNN, for example, was a very good example. They have their ads isolated in iframes, and although they have real-time bidding and such, it was stable and the rules were fine. BBC, on the other hand, they use the real-time bidding code in the same as their main site, so they are not even aware who is going to display the ads in the once this is served to the client. So CNN good, BBC didn't work so well. Twitter, for example, they are using CSP themselves, and they have a well-architectured site. So user content and their main site is separated. So here it's worked very well. In terms of security, we saw a lot of sites are using, maybe not too much surprise, eval inline. Still, as an added advantage, this could prevent data leaks. So, I mean, we saw drawbacks with both these approaches, but we feared maybe as future work can this somehow be combined. So can we use this high volume, noisy data set with low volume but vetted data, maybe combine this in a way that would allow to leverage benefits from both. Maybe still a way to use machine learning to look for obviously suspicious policies which should be removed, or maybe we can just make this crawler better to be closer to just using a lot of people. In terms of discussion, we also reached out to a couple of security engineers that were also setting up CSP, talked to people from Square and Etsy, and also some others. And one of the most important things for them was to keep inline script. So, I mean, they have all these sites which already work well, and having to move inline script to a file is both going to make the site slower, and it's also going to lead to cost. So changing these applications is just expensive. And, well, so another thing is that enforcing CSP and these extensions is generally considered a bug. And so what we were suggesting in our paper is to, first of all, isolate ads similar to how CNN is doing it. It just makes this much easier. Adoption of the frameworks is important, so apps which are being used by a lot of people, if they're starting to use CSP, this is going to impact this landscape a lot. Also, browsers should not enforce CSP and extensions, but this is on the way. So we know from so both Chrome and Firefox are in the process of considering this a bug. We know that the Chrome people read our paper, so we hope we were able to provide some motivation for making this happen. And during this project, we also had some vendor contact. So PHP MyAdmin, which on a positive note is the #1 user of CSP. So they have in the top 1 million, over 400 sites are from them because they decided to use CSP in their setup, which is good. But so this was funny. We saw on their site in this demo setup they completely misconfigured the rules. They overrode a rule in a way which just blocked what they were actually supposed to do, and they were blocking their own code. Well, so this resulted in so we reported this. It resulted in a fix. With how much more time do we have? Oh, okay. Okay, yeah. We also had we also found something with Facebook and the GitHub. Well, I guess I just skip this here. So, in terms of conclusions, so we saw that CSP adoption is way behind any other security relevant header, even if they are just serving a niche purpose. Although it's well functional and holds this promise of being really helpful. So those sites that do deploy it don't use it full force. So they could use it and to protect their sites way better than they're actually doing this. We also just deriving these rules automatically is hard. So it's not as easy as probably envisioned by the original design. There's a couple of obstacles which are tough. And so we think CSP holds this great promise of helping in the future. And version 1.1 is actually addressing a couple of these problems. So including inline scripts is going to be integrated better. So this can be whitelisted by a hash or a nonce. So we think that a lot of these sites which are using inline script heavily will just have this option of with minimal impact add CSP to their sites. Thank you for your attention. I'm happy to take questions.
Thank you, Lars.
All right. in CSP 1.0, the policy has to be delivered with an HTTP header. In 1.1, it can be delivered by a meta tag, but that's not supported yet, at least not in Firefox.
Yes.
Do you think this is a problem that you have to deliver the policy with an HTTP header when it comes to adoption?
I generally think it's better to do it over an HTTP header than over a meta tag, because I mean, the earlier you send this as a server, the more likely you are nothing happens before you send this out.
But do you think it actually makes it more difficult to implement for people, for websites?
I guess, because otherwise this wouldn't have shown up in the standard.
And a related question, let's say we have a web host that gives users subdomains where they can host pages, but they can basically just host static files, so they don't have any control of the servers. Like GitHub pages, you can store static HTML files, but you cannot control the headers being sent. Do you think it would be possible for such a host to actually implement a reasonable CSP policy for all these users that have subdomains with just static files?
That might be tough. It depends on this CMS system or whatever you're using. If you can say in advance, this is what kind of policy would make sense, it's good. But if you're just loading stuff from a database, which is free-form HTML, then no. You need to be aware of the structure of the site.
Other questions?
About the CSP reports you sent, well, if there's a violation. So, I mean, somehow, well, you can argue if you find those useful or not, but as much as I know, yeah, the usefulness is kind of like questioned. Do you think like there could be something more useful to be sent by the browser, or should developers go more for different kind of tools to derive the perfect CSP, so to say?
Well, I think these validation reports are very useful. I mean, you want to know what's going on your site. It's also a good mechanism for you to know whether somebody's modifying the site in flight maybe, or whether you're being attacked. So I think the validation reports are good as is. Just the way it's being used right now, that enforcement over extensions just really creates all this noise. So that's a problem. But once this goes away, I think it's perfectly fine. Does this answer your question?
Yeah, absolutely. Yeah.
Oh, okay.
Thanks.
Let's thank Michael again.